Okay, in this example, we are going to study how to use generating function to solve a very difficult counting problem. This is just an illustration on how generating function is useful for counting. This kind of question is very difficult, and therefore, this kind of question will not appear in exam. This is just an illustration, okay? So for example, we have a bag with n fruit, and how many ways can you fill a bag with n fruit? And let's say n is 100, okay? Number of apples must be even. Number of banana must be a multiple of 5. At most 4 orange. At most 1 pear. Okay? Then how do you do that? So we can solve it using generating function. If you try to solve this by tree and then you use the binomial coefficient, that tree will be extremely big and it's impossible to solve it by brute force. So you have to solve it by generating function. So how many ways can we select apple? Apple means even, right? So 0, 1, 0, 1, 0, 1. What does it mean? It means 1 way for 0 apple, 0 way for 1 apple, because this is odd. For 2 apple, take it. 3 apple is odd, so 0. So go on. So with this, we have the following apple polynomial. I call this apple. How many ways can you select banana? It can only be a multiple of 5. So this means what? X to the power 0. 0 is also a multiple of 5. Okay, so 1. What does it mean? It means multiple of 5. Okay, that means you buy 5 banana. What does it mean? It means you buy 10 banana. What does it mean? 15 banana. All these numbers are multiple of 5. At most 4 orange. So no orange, 1 orange, 2 orange, 3 orange, 4 orange. So this is orange polynomial. At most 1 pear. No pear, 1 pear. Okay. Then you want to find a way of filling your bags. We multiply all of them. Why? Because it's product rule. So for the product rule of the generating function version, we just multiply the apple polynomial, banana polynomial, orange polynomial, and the pear polynomial. We get this thing. So now we have this fruit polynomial, which is this bracket multiply this bracket multiply this bracket multiply this bracket. So first, we can simplify the thing. So first, this guy is this guy. What is this? This is geometric sum. Okay, this is a geometric sum. You learn it in high school. Okay, so we have this thing. Then what's next? This is what? Infinite series. What is this? Infinite series. We can use geometric series to get this bracket become this bracket, and also this bracket become this bracket. And then now, from this term, you can see this guy and this guy are the same. So we cross this guy, and this guy are the same. So let me highlight it. So this guy is this guy, and then this guy is this guy. So they are the same. So we cross. And then what's next? Well, for this 1 minus x squared, you can split them, right? Then you found that one of them is the same as this guy. You cross. So what you get? You get 1 minus x squared. You know that this thing is basically 1 over 1 minus x differentiation. Okay? So what next? This guy equal to this red thing, which is basically geometric series. That means you have to take differentiation of each of them one by one. So it gives you this funny expression. So what does this funny expression mean? This funny expression means if I plug in this 1, 2, 3 as n plus 1, so this is the meaning of x to the power 0 with a coefficient what? Coefficient 1. This is what? X to the power 1 with a coefficient 2. This is x to the power 2 with a coefficient 3. You find that all this term is x to the power coefficient, but then the coefficient is the power plus 1. So that means what? There are n plus 1 way to select n fruits that fulfilling all these conditions. So if I have 100 fruit in my bag, I have 100 plus 1. That means 101 way to select fruits such that this is true.